All right. Well, welcome to another episode of the podcast in our series that we're doing on the architecture of reality. We talked yesterday about Kant and how he wrote an influential book summarizing Newtonian physics and really pushing the idea of a mechanistic universe sort of into the next uh, phase of history. And he did that some by imagining backwards, taking the machinery and imagining backwards and saying, so what would a way of this come, how would this machinery come into existence using nothing but materialistic explanations? And so that was one really influential thing that he did. But he also just shifted to this mechanistic understanding of the universe that Newton put forward, although Newton wasn't putting forward, in his mind, he wasn't putting forward a fundamentally different view of the universe. He was explaining that he understood the limitations of science, and we know that because we now have his works published on Newton's papers, where he wrote on a lot of other subjects, especially on alchemy, and so we have a better understanding of his understanding of the world. Um, they sort of disappeared and then showed back up in auction, and it really shifted our understanding of Isaac Newton, because got to see him working broadly and talking about cosmology and talking about how that by studying the world both in its largest capacity and then in its smallest capacity in alchemy and the transmutation of metals and different things like that, that you were seeing the divine hand, right? That's how he thought of it. So in many ways, he wasn't that different than the medieval the medievals, but he understood. He wrote the Principia Mathematica that put forward the understanding of universal gravitation. So the big change in the way that the universe was conceived was not that it was now ordered or that it could be predicted, or the medievals believed in a predictable, ordered universe, but it was that the force that we interacted with here, that the same forces, the laws of motion, the gravitational force, that the same forces were everywhere. So if you remember in the medieval understanding, the celestial bodies that were above the moon uh, were were working on different principles because they were unchanging, and we were dealing in a world of change. We were dealing in a world that had been affected by sin. We were dealing in a world that had evil involved, and above the moon, you no longer had that sort of uh, extra fly in the ointment, so to speak. So they continued to move purely based on love. There wasn't any sort of fight with sin going on. There wasn't any evil. And so, um, what the really big shift was not from an ordered, rational universe or from a disordered, irrational universe to an ordered, rational universe. You read that a lot. But that wasn't at all something that was questioned. Right? That wasn't what Newton was even demonstrating in his Principia Mathematica. What he was demonstrating was that there wasn't a separate set of physical laws for terrestrial and celestial objects. The same physical laws could be used to describe the fall of an apple and the moon's orbit. So he's dealing purely in terms of physical laws, and he's got the first law of inertia, the second law of force and acceleration, the third law of the equal reaction. I'm pretty sure that's the order. He's able to really replace some of the medieval notions of what caused motion. Right, Aristotle and other medieval Aristotle wasn't medieval, but Aristotle and medieval scientists all believed that motion required a continuous force, right? That there was a continuous force, and so things came to a stop if there wasn't a continuous force added. And what Newton really came to understand is that, or came to describe, is that forces act in pairs, right? So if something's slowing down, it's not because that things naturally rest, but that there is a force being applied by friction, right? So to understand in terms of force and mass, um, and the biggest difference is that the force functions the same way on the Earth as it does in the heavens, right out in space, um, was a major shift. So um, you this it made it possible to have to do some of the same kind of predictive mathematics that you did on the stars. You could do that now, the same sort of predictive mathematics now with a flying object, with a flung object, that sort of thing. So the condition, if you know the conditions of the system, then the future motion can be calculated with precision here on Earth, the same way future motion can be predicted in the heavens. And that is a major shift and a change, is the idea that there are universal laws of motion, universal law of gravity. So it's not that they didn't believe there were laws of motion or that there was predictability, anything like that. It's the idea that they were universal to the heavens and the earth both. And so that idea of earthly and maybe cosmic phenomena, earthly and cosmic things, that they were integrated in the same system of forces, or gravitational force, the the laws of motion. That was fairly revolutionary. But for Newton, he wasn't thinking it in a shift. You hear sometimes it was like a shift from a mystical view of the universe to a rational view of the universe. The medieval view of the universe, the Aristotelian view of the universe, was incredibly rational, predictable. It was unified below the moon and above the moon, right? That was the big change. And that's not really a threat, because it really was an Aristotelian view that he was arguing with. It's not like he was arguing against the Bible or something. He was writing books of theology. He was himself a very devout person. But the predictions through math that he was able to make really suddenly get very specific, and so that was how everybody knew, oh, he's made a good move. But he didn't think he was making a change to cosmology the way that we look back and talk about like he was. And that his alchemical writings cover things like the Philosopher's Stone, the purification of substances, transmutation of metals, and all of it requires the devotion the devotion and morality of the scientist or the alchemist in the process, because he believed that the natural world still had hidden truths that revealed the divine order of the universe, right? And that is so. In that way, he's still fundamentally medieval. He still fundamentally believes that the world is an allegory of divine life, an allegory of the divine life, and it's he was actively and experimentally trying to create a philosopher's stone, you see in his papers, which required full devotion to God and an exceptionally virtuous life. So it's a really it's really interesting because I think we tend to think of the pure scientist as the one who really makes changes. Um, Really, Newton saw that uh, his search for God and the hidden knowledge of God, the knowledge of God hidden in creation, um, as the thing that was really the important thing that he was doing, right? That he was trying to live a virtuous life before God, because he believed that even these natural laws that he was discovering were God's work, and that alchemy might unlock the spiritual insights hidden in matter or hidden behind matter. So Newton didn't really consider what he was doing a shift away from a previous cosmology, but his shift in metaphor from liturgy to mechanism does have enormous effect, but it's mostly through, primarily in his day, through Kant's book, The Universal Natural History and Theory of the Heavens, in 1755. When Kant published that book, he popularized he popularized uh, and he did a good job describing Newton, but what he did was he popularized the idea that this was a shift in cosmology, that it wasn't just a shift in metaphor, right? That it was actually a shift in cosmology, explaining the formation and structure and mechanics of the universe through natural laws. And this is the big part, without divine intervention. And that's what Kant argues for. So, which Newton wouldn't have held to or wouldn't have been okay with. He was deeply devout. So the mechanics of the universe without through natural laws without divine intervention, um, he really is the one that makes the shift. And I think that the idea that the laws of nature are enforcing onto nature its movement is a major part of the shift in metaphor. So it's almost like a cosmological legalism, right? That the laws are the things that are making the heavens do what they're doing, when in fact, laws in the sense of a scientific law is a descriptive. It's not, the law is not the force. The law is the descriptive, but that's the subtle way that Kant shifts the metaphor into a mechanistic universe where the laws of nature are the things that cause nature to do what it does, right? The laws of motion are what causes the motion, but that's actually not the way. That's bad scientific philosophy, bad philosophy of science, right? The laws of nature are descriptive. We get a description. We see the same thing happen over and over and over, and then we put in to describe the expectation that's going to happen again next time, the law of nature. But that isn't actually giving us an explanation of the force, of the cause, right? It's a description that is gathered from the evidence of seeing it happen a lot of times. But that subtle shift to a mechanistic view of the universe where the laws of nature become the cause that Kant posits really end up shifting and changing the way that we think. And so the phenomenal realm, if you remember from the last time when we talked about Kant, the phenomenal realm consists of things as they appear to us, and they work according to natural laws, right? That's what Kant brings. Now, the noumenal realm, it might refer to things in and of themselves, things independent of our perception, things that we can't grasp with our senses, and maybe the noumenal realm functions on a different set of laws, but the phenomenal realm functions on natural laws. That is what Kant took from his readings of Newton and pushed. It wasn't what Newton pushed, but it was what Kant pushed using Newton's mathematics, because he was one of the greatest mathematicians the world had ever seen, right? And I believe Leibniz was the other one. They both independently created calculism, right? As mathematicians, they were above and beyond everyone else. But Kant kind of riding on the coattails of Newton's math, ends up shifting the metaphor system that we use, and trying to argue that natural laws are causes and not just descriptions.